welcome. Hi, my name is Travis.
Hi, Travis.
And that's perfect because welcome to a big group therapy session on dev environments. So just quickly, who am I? I am the lead of our platform engineering team at Game Changer. Game Changer is the premier platform for amateur sports data. We're based in Manhattan. We're totally awesome and fun to work for and do a bunch of cool stuff in Python. You should totally talk to me about it after the talk. So to the talk, my resolution is crazy on my monitor. What this talk is about is dev environments. So we're going to have to go through a couple things as part of this talk. The first really important question is, what is a dev environment? What do we expect a dev environment to do for us? And how do we know if our dev environment isn't doing that job properly? We're also going to go through the sort of current state of the world of like, what have we tried to do to make our dev environments work well? Where has it worked? Where has it not worked? Once we go through that, we're going to talk about containers and how we might be able to use Linux containers and projects like Docker to get us to the next level in our development environments and maybe improve on some of the sort of deficiencies we've seen in our existing solutions. And at the end of the talk, I'm going to move from sort of talking about theoretical, oh, it'd be really nice if we could do this, to actually getting into concrete details of what sort of tools we have available to us to realize these theoretical, really nice dev environments we're going to see using containers. So first question, what is a dev environment? The short answer, it's all of this crap. So everything on a given machine that influences how you write code and how you execute code and the effects of the world and the rest of the file system and all this other stuff on your code, that's part of your dev environment. So if you've got like a Mac like I do and you're just punching around and saying Python myscript.py, it's basically everything. So it's not only the language runtime, the libraries you have installed. There actually are a lot of other components that you typically don't think about a lot because it's not a part of what you care about as someone writing code. But stuff like, what language libraries are installed? What sort of kernel am I operating under? Do I have a network card? Is there something plugged into the network card? All of that matters if you're going to write a script that says like request.getGoogle.com. You're just thinking about that line, but everything all the way down needs to work for that to be able to really do what you want it to. And all of that's part of your dev environment. So a sort of more formalized way to look at that than just a disassembled MacBook is this sort of inverted pyramid we have here. So at the very top of the logical sort of layers of stuff that's going on in your dev environment is what you actually care about. It's like your code. That's why it's like the biggest slice. You care about your code. That's where most of your attention is going to be. But as we talked about, whether or not your code can run is influenced by all these other things. So your libraries and your runtime for the language you're working on, but also a lot of other stuff that's not even necessarily related to Python. And that's going down into this place I'm going to call user land, which is basically everything above the kernel that's not directly involved with the code you want. So like your system libraries, do you have the right compiler installed to run C extensions? All that stuff is part of user land. And then even further below that is your operating system and your kernel. And even further below that is your hardware. And there's this sort of pernicious pattern here where the stuff you care the least about is the most complicated. And if anything breaks there, it's like really awful for you to have to deal with and like figure out what's going on there. So there's really a lot going on, even if we're going to write a simple Python script in a dev environment. If we have to deal with all of this all at the same time, there's a lot to think about. So I've shown you two representations of a dev environment. Here's a third one. It's just like a giant ball of crap, just like all twisted together. And especially if, say, I'm just writing code on my Mac here with no virtualization going on, it's like literally everything on my Mac impacts everything else. And so maybe I just care about one of these little threads here. But to get my code to actually do what I want, I have to consider everything else that's going on. And that's really hard. So some of what I want to talk about today is how we can reduce the scope of this giant complected ball and get it to a place where it's more manageable for us and it makes it easier for us to write and manage our code. So how do we know what our dev environments are supposed to do for us? If those dev environments are failing, what does that feel like? So if your dev environment is failing you, if you have any of these problems. So first of all, if you can't get your code to work at all, your dev environment is failing you. That's an issue. Also, if our dev environments are helping us do our job instead of hindering us, it should be easy for us to reproduce and share our results. If you've ever had the joy of a new laptop tempered by, oh crap, now I need to spend 3 days setting up my dev environment, you have this problem. And that affects other people as well. So if you bring new people onto your open source project or your company and they have to spend days doing this, they have that problem. Also, our dev environments we should be basically masters of our domain. If we should be able to test our code properly, for example. We should be able to run exactly what we want to run. There shouldn't be sort of blockers in front of us, and our environment should be helping us rather than, again, hindering us from doing that. And lastly, once we get all that to work, we should be able to make changes to our dev environments without being worried that we're going to destroy all of this work that we've done and break everything. And again, when you have that one big complected ball, it's really hard to have that confidence because everything affects everything else. So we're going to see how we might be able to make this better. So this is what a bad dev environment looks like. I have some bad news. We as a community and as an industry are not doing a particularly good job here. Here is a choice Hacker News comment from 2 weeks ago from a person who decided to write this in a very dramatic style, which is why it got featured in a talk. So this person runs a Postgres database in production, and they were running SQLite for testing. So SQLite, it's like easier to start up, but it's not the same thing as Postgres. And everyone was like, why are you doing this? He said the alternative to testing of SQLite is not testing at all, because there is limited time for testing, and setting up a proper database for this is so much more trouble. The choices are not good test versus bad test. They are test with issues versus no test. So this person's dev environment is failing them. They can't do something as simple as run a database, which is, we run software. That's what we do. We should be able to do that. And that's preventing them from testing their code properly. So I want to start breaking apart this problem now and talking about some different ways we can think about it and what we've basically tried so far. So let's go back to our inverted pyramid here. And in this context, we're going to try to write a very, very simple Python app. I'm not going to write anything here, but let's say I end up writing some code. It takes one library, which is request 2.6, and it uses Python 2.7. So for that code to be able to run, I need all of those things to be true, because the code is written with these assumptions. And so let's say I've got it on my computer. Everything's working. Everything's cool. And I give it to my friend. And I'm like, hey, friend, you should run this totally awesome Python library I wrote. All you need to do is run pip install request 2.6. So unfortunately, our friend runs this. Turns out she was running like a super important program that uses request 2.5. And so when you do this, request 2.5 goes in the trash. So pip is just going to throw that away. It's going to say, you can't have both of these. They can't live in the same layer of our pyramid here. And we're Python people. This is a problem that most of us have had. So we have this conflict between two versions of a thing that can't live in the same version of this pyramid we have. So we need to come up with a way to let them sort of both exist, live harmoniously, because my friend wants to be able to run her code and my code. So that's like a reasonable thing to want to do. So how can we do that? So let's go back to the concept that we have here. And let's say, so I know that request 2.6 and 2.5 aren't going to live together in harmony in the same version of this pyramid. So what if I cut this in half? And everything below the pyramid, I'm going to keep one version of this. So I'm going to have one version of my hardware, my kernel, and the rest of userland that's not Python specific. And everything above this, I'm going to let myself create multiple copies of this. So over here on the left, she can run my code with request 2.6 in Python, and that's going to only be able to see what's in there. And on the right, she can run her code. And so if we do this, both of these apps can live in harmony on the same physical machine, and they're going to work. So there's good news. This is a real thing. This is called a virtual environment. It's a Python-specific concept. A lot of you have probably used it before, and it's a way that we can solve these version conflicts. And so you may be asking what this has to do with dev environments. It's a great question. And it's going to lead us into this concept of scalable isolation. So a virtual env is really nice because it lets us put the requirements for one thing in one unit of isolation, and it's not affected by other installed dependencies we have outside of that unit of isolation. And that's not only useful for getting different, conflicting version requirements to interoperate. Like, that's one very specific use case. But it also makes it easier for us to do just about everything in terms of debugging. I'll talk about why. So this is an actual Python module dependency graph that I took off the internet from someone's project. So It doesn't matter what's in there. It just matters that it looks heinous. So let's imagine that we're not running in something like a virtual env. And so every Python project we've ever installed is living in the same box. Like they can all see each other and are influenced by each other. Now the reason this is hard, let's imagine that we have a problem there on that little tiny one in the middle. If we're going to go fix that problem, we need to think about all the other stuff because they all impact each other and have the ability to conflict with each other. And that's inherently hard. I mean, to approach this problem at all, you're going to need to put the context of this graph in your brain. So let's imagine if we didn't have to put everything in the same unit of isolation and we could split them up. We could have something that looks more like this, where we have a bunch of smaller units of isolation. Each one has a very specific thing. And the reason this is going to help us in pretty much everything we want to do is now if we have a problem in this little cell, this little library, when we approach that problem, we can immediately put the other units of isolation out of our minds. We know the problem isn't there. We know the problem isn't affecting things that live in those other units of isolation. The concept of isolation, when we apply it to our dev environments, allows us to hone in on where the problem is. It lets us to keep a much smaller amount of context in our brains. And it gives us a way to make that big complected ball smaller. And that's going to help us do basically everything. So unfortunately, virtual environments are not enough to solve the very general problem of development environments. So first of all, they're not even enough for just Python. You can't encapsulate every piece of a Python app necessarily in a virtual environment. What if you have C extensions? What if you have conflicting system libraries? Virtual environments are not going to save you there. Also, it's very Python specific. You may know less than 100% of the world's code is written in Python. This presents us a problem. One, it's a problem that everything isn't written in Python, but more generally, it's a problem that virtual environments are not going to let us apply this isolation concept, which we've seen can be very powerful. It's not going to work, so we need something that has more isolation. And also, a lot of the times we want to run things that aren't our programs, like a database, or like a bunch of databases, or some crazy Java framework thing that does something with like a pipe or something. And we're not going to be able to run that in a virtual environment. So they're not enough. So let's try again. So our problem, virtual environments are really cool, but they don't offer enough isolation. So how much isolation could we get out of this model? So let's recall that we're not talking about distributed systems here. So let's limit ourselves to one computer. So if I want to use my MacBook here as an example for this, how much isolation can I get? Well, the obvious answer is I have one MacBook, and everything else is just bits floating around. So what if we did that same trick, but this time we're going to cut this right above the hardware level. And so we're going to allow ourselves to create units of isolation that contain everything other than the hardware. So like kernel up. And each of these will operate completely separately from each other. And with this, you could isolate basically anything. You could definitely isolate like, Node or Java in here. You could definitely isolate a database in here. You could isolate basically anything other than your physical machine. So this is also totally a real thing. This is called a virtual machine. And there are a lot of implementations out there. The ones you're probably most familiar with would be VirtualBox or VMware. And Vagrant is a very nice tool to help you sort of manage virtual machines on your device. And virtual machines, they definitely solve the problem we have with virtual environments where there wasn't enough isolation. However, virtual machines themselves have one huge disadvantage, and that is that they are big and they are slow, very slow. Turns out running a whole different kernel and having multiple kernels be able to cooperate with each other takes a lot of very clever engineering, and it doesn't work super well. So you could have one or two or maybe 3 virtual environments just fine. You probably can't have 5, and you definitely can't have 100 on any normal consumer laptop. So the issue, and that's a bigger problem than just performance. The issue there is that we can't scale out our units of isolation. So you can imagine if it's great that we can isolate basically anything here, but we can't say, I want a virtual machine just to run my code in, and I want a virtual machine just to run my friend's code in, because that scales for about 5 minutes, and then you're out of system resources. So what ends up happening in most virtual machine-related dev environments is you have a virtual machine that you start with, and you can, it's a little better than just telling someone to run stuff on their random MacBook, because you can give them like a starting point where it comes with, it comes with Ubuntu 12.4, and we do all this stuff. And it gives you a place to start, but it doesn't actually solve the problem of the big complected ball. Everything still has to go into this one virtual machine. So what we're going to end up with is pretty much the same issues we had before, where it's a little easier to get started. So this is, personally, this is where I was in my development environment world until about 2 months ago. And it was really painful. You can layer stuff like Chef or Ansible configuration management on top of it, but really you're solving the same problem where you're just managing the big crappy ball. What we want to do is get rid of the big crappy ball. So let's try this one more time. So you can cut here, and we'll get something like a virtual environment in Python, which is scalable but doesn't have enough isolation. We can cut here, and we get a virtual machine, which is very isolated and not scalable. So the clever ones among you can guess, what if we cut it here? What would that be like? That's a great question. Let's answer that question. So let's cut it above the kernel and say, I only want one kernel, because as we saw, having multiple kernels was like just a total nightmare, and we couldn't scale that out. But everything above that, including my system libraries and whatever processes I have, and definitely encompassing, like in our Python example, Python and the libraries and the code, all of that we're going to put into its own unit of isolation. And this is going to be really powerful, because we're going to get the two different properties we wanted. This is going to be scalable, and it's going to give us a unit of isolation that goes deep enough that we can run basically anything in it. So we can take these units of isolation, and we can put just what we want in them, just very minimal set of stuff. Like, here's just like the Python binary. That's all you need, and like just the libraries it needs. And other than that, you're going to go through the kernel normally, and everything's going to be happy. And so what happens when you do that is that these can get pretty small. And that's what's really critical to helping us scale them. So one, they're very small, and two, we're not replicating the kernel, which is just a non-starter. So not only we can make them small, and as a result of making them small, we can have a lot of them. So this is, if we cut here, we can get to this sort of ideal of scalable isolation. So as with the previous two examples, this is totally a thing. And it's called a Linux container. So you've probably heard of Linux containers. The big popular project dealing with them now is Docker, which has this totally awesome whale logo. Docker's been doing a lot of work, and Linux containers are actually like 7 or 8 years old. Docker's been doing a lot of recent work to make it a lot easier to use containers, and they've also been doing a huge amount of ecosystem work around making it easier to share containers, use the tooling. We'll get into it a little bit. Okay, cool. So we have this brand new, shiny, awesome thing called a container. But I've been very much at like the theoretical level up until now. So let's see how we could actually apply this technology to our development environments and see if it solves this list of problems that we had from before. So recall, if our development environments aren't doing their jobs, these 5 things all become really difficult. So if we take the concept of a container, can we make these less difficult? And let's just go down this list, because this stuff's all really important to me, and I think it's all really important to you. So let's see what we can do with it. Step 1, get your code to work at all. So as I sort of talked about a little bit before, all we need to do with a container is we need to put in exactly what we need to run just like one process. Like, I just need this container to have the requirements to run this Python code. So I'm going to give it my Python code. I'm going to give it exactly the libraries I need just to run this app. And I'm going to give it a Python interpreter. And I'm going to run that, and it's going to work. And so just to do a reminder, all of the stuff that goes in the container, the level below that goes straight to the kernel. So as long as you're shipping the container to a sort of machine with a kernel that makes sense, which generally you're going to be sticking on the same Linux kernel or whatever you're working with, that's going to work. So we can get a small container. We don't have to worry about 100 other things. We just worry about what we need to run that app, and we can ship that off, and that'll work. So getting our code to work at all is pretty easy with containers. The next big step, how do we reproduce and share our results? So Docker, one of the things that Docker has added, as I mentioned, was making it easier to share and reproduce containers. So there's two really simple ways to do this. Way one is you can take a container, you can do whatever you want to it. You can just do random bash commands, you can delete stuff, add stuff, whatever you want. And then you can take a snapshot of that container. And you can say, just take exactly what I have right now, save it in like a tarball somewhere. And anyone later on can download that, and it's going to look exactly like it was when you saved it. So this is like the quick and dirty way to do this. It's pretty similar to like a disk image if you were doing VM stuff before, but it's like super fast. And because the containers themselves are pretty small, it's not like typically a multi-gigabyte VM image. It's like a couple hundred megabytes with Python stuff in it. The better way to do this for reproducibility is Docker gives you a way to list out, basically, here are the steps you take to give me a container that just does what I need. So one of the neat things about Docker is that the sort of to-do, here's the example I'm going to use during a talk examples, actually tend to look a lot like what you do in the real world. So here is a very typical Python app run in Docker. All I'm saying is start with a, let's say, Debian file system. That's not going to run like a kernel from a full VM. That's just a file system. Install Python in it. Add my Python code. Run pip install to install my Python dependencies. And when someone runs this container, I want you to execute my Python app. That's very actually representative of what a Python container typically looks like. So you can write this file, you can share it with anyone, and they can run these instructions to recreate the container that you made. So reproducing and sharing your results with Docker, pretty easy. Next step, test your code properly. So going back to our Postgres example from Hacker News, Docker enables a really, really awesome testing flow. And there's pretty much nothing analogous to it in the sort of VM one system world. So what we can do is we can say, I have a Python app running in my dev environment, and it's talking to a Postgres instance. And that's fine. And they're running. They're happy. I can do whatever I want to with them. Now let's say I want to run test. So with containers, you can run tests completely separate from everything else that's happening. So you can spin up a container just to run test. And you can have that container have all your Python code and the libraries and everything, and you can even pre-install your testing requirements into it. So your tests can become very fast. You just take the container, you run it, you give it the new code. And the other neat piece is you can spin up a totally separate database instance for this trivially. It's just the exact same as the one on the left. It's just another container. And the resources for this tend to be pretty small. The startup times are good. You can spin these up, test your stuff, and blow these away. And the whole time, you haven't touched the stuff on the left. And you haven't done any crazy, oh, we'll spin up a test container on this weird port and give these weird settings, or sorry, a test database, which is what we used to do all the time. And the last step is changing your dev environments with confidence. And this is where scalable isolation is really going to shine. So let's say I have my big bunch of containers here that are running my dev environment. If I'm making changes, and let's say I visit a total apocalypse on this container, two things are going to happen. First of all, that container is, going to explode. But nothing else is going to care. And it's because they're, again, totally isolated from each other. This big Python container in the middle has no idea what's going on over there. And that's hugely important for being able to affect change. Because if, obviously, I was in this one that blew up, changing things, it's going to be pretty obvious to me, well, that didn't work. And I don't have to go, if you can imagine doing this, you can do something on a big VM complected ball, and it could break something else you're not going to discover for 2 weeks, because they're all related. But with this, you're going to get pretty immediate feedback. Either it's totally broken, or and that one container has exploded, or your change it's probably working, the container's still there, but no matter what you did, you're not going to affect these other containers. So you can make changes in your dev environment, and because the scope of that change is so limited, it's generally pretty easy for you to figure out whether it worked or not. Okay, so as we've seen, everything is sunshine and rainbows. You should use Docker for everything. It will make your life better. People will find you more attractive. Obviously, there are no downsides. So that's not true. So there are actually quite a few downsides to this sort of container-based flow that I'm going to get into now. And let's see what they are. So I've been talking the whole talk about how isolation is such a big deal, and it's so great. and it's wonderful, and it really is. But isolation also introduces a whole class of problem that you've never seen before if you haven't been using isolation. So it's sort of a double-edged sword. It's nice because nothing can interfere with each other, and it's sort of tricky because nothing can interfere with each other. So if you're over here, and let's say this part of the stack is like my actual like Mac normal operating system. If my Python app is over here, and I want to like get a shell and do Python stuff, or copy files around, or access that Python's web service on a port, that's all really easy if you're just on one computer. How do you do that now? That's the whole point of it, is you can't cross these boundaries. And yeah, and maybe I've got a database over here too, and I want to do a database migration. How do I get over there? How do I get my scripts into that container to run these database migrations? This becomes really hard, and a lot of us have never seen this be hard before because we never had this level of isolation. So that's an issue. Also, if you take this approach to its logical conclusion, you end up with this vast menagerie of containers. And even though each of these is small and simple by itself, the collection is pretty daunting. Like this is, like numerically, this is like pretty accurate in terms of where our stack is, and we're a fairly like small company. So managing this is complicated. It's not complex. It's simple, but it's complicated. And that's the perfect kind of problem to solve with tooling. Also, Docker has a really good story around sharing and reproducing one individual container. But one individual container doesn't give you a dev environment. A dev environment is a collection of containers hooked up in such and such a way with such and such config settings and all of that stuff. You need a way to share and reproduce the collection of containers, or your dev environment isn't really shareable and reproducible. So how do you do that? And the last one, which is a big problem, particularly for me and I think a lot of you who don't run Linux on your main machines. So I mentioned these are called Linux containers. So if you're running Linux, you can just do this. You can just run Docker. It's so cool. If you're not running Linux, you need to run a virtual machine to run Linux, and then you can run Docker on that, which exacerbates all the other problems I was just talking about, because now not only do you need to navigate containers, you need to navigate into a VM, into a container. And there's a lot of, again, it's not complex necessarily, but it's complicated. You got to do a lot of boilerplate and annoying stuff to navigate all of this. So how do we fix this? This sounds crappy. You said this was going to be so wonderful. This sounds terrible. And you're right. So the way we're going to fix this, we're all software people here. We're going to write tools, obviously. So let's talk about some tools that help us do this. So Docker has done a lot of work in their ecosystem solving some of these problems. So 2 examples are Docker Machine, which is going to help you set up that virtual machine we talked about. If you're me running on a Mac, you need a Linux virtual machine to use Docker. So Docker Machine helps you do all of that. And Docker Compose gives you a way to manage the sort of multi-container configuration problem. So how do I share how these like 8 containers are rigged up together? The answer is Docker Compose with some caveats. The issue here is that these are fairly like low-level tools. It's like, how do I rig up multiple containers? Low-level problem, really. How do I set up a VM? Low-level problem. And as part of our general development environment flow, we typically have some higher-level issues than this. So I'm going to talk about some of them now. Like, if we were to use this in our dev environments, what problems do we really need to be solved by our tooling that aren't addressed by this lower-level stuff? So the big number 1, like headline all the way up here problem is usability. For our development environments to be effective, we need to be able to share them not only with people, I'm going to use this term to refer to myself, like people like us, like terminal jockeys who are like very comfortable running, oh, just run this Docker command with these 8 flags and you'll get a shell. And you'll be like, oh, obviously. So there's a class of person for whom that is like doable. There are a lot of people that need to be able to run our code where that's going to be uncomfortable for them, that's going to slow them down, it's going to prevent them from doing what they want to do. So I should, in my ideal world, I should be able to give my dev environment tools to a front-end developer who's not as comfortable in the terminal, or to a designer who, anytime they're spending in the terminal, is definitely not what they want to be spending their time on. And it should help them achieve their goals. Also, we just write code. Like our flow is we're writing code and we want to like see what the change does. We want to run it in our containers or whatever we're doing, but we want to have a fast feedback loop there. We also want to be able to reason about like, what are the errors? Why did that break? There's a lot of stuff that goes into running a dev environment with a constantly changing code structure that isn't addressed by the more production use case where it's like, here is a container, run the container, thank you, I will never touch it again. And a lot of the tooling has been understandably focused on these more production use cases. So to support changing code all the time dynamically, you really need a tool that's specifically focused on dev environments. As I said, as part of that, we want to be able to say, I'm running these 6 containers which all rely on this one repo, which I just made a change to. So I want to make sure those 6 containers all get that new code because it's important that I see my changes that are going on. Also, we don't want to just be able to run the cool test flow we talked about with a fresh Postgres container and our cool test container with our test requirements installed. Once we get that running, we want to be able to share that in an efficient way, ideally in a way so that whoever gets it down the line doesn't really have to know the details of that at all. They can just say, hey, like, test my stuff, please, and it will work. As we talked about, there's a lot of sort of layers of virtualization you end up having to navigate here through a virtual machine across different containers. And that's a very like use case specific problem where we want tooling to be able to help us do all of this. Again, we don't want to be running, just run these 8 simple commands to copy a file from here to here. And the last piece is we want to be able to mix and match our dev environments. So as an example at Game Changer, we have like 12 services right now, some in the like low double digits. And I want to be able to share how to run all of those services with everyone at my company. But typically at any one time, I'm only actually working on like 1 or 2 of those. I don't want to run all 12 at the same time. This is a big problem with like virtual machine setups is you end up having to install everything. And then you have to say like, okay, now do I have to run everything? Like, how does that work? Big ball of complected crap again. So ideally, we should be able to change our configuration on the fly to only run the stuff we really care about. So as of about 2 months ago, this was a really big, all of these were really big unsolved problems in the Docker ecosystem. As we've been talking about, there were low-level tools to help us solve some of these problems. But we looked at this, we saw the potential of using containers to do all of this. We were feeling a lot of pain with our virtual machines, but there wasn't anything really out there that addressed all of these specific issues. So we wrote something to address these specific issues. So we wrote Dusty. It's a new tool in the Docker ecosystem. It's written entirely in Python. It is a command line app that is going to address the needs that we need specifically to use containers for our development environments. So it's very much a high-level tool. It knows about things that no generic tool would know about. Like it actually, Dusty knows about the repos you're using. It knows this container uses this code. It does a lot of stuff specifically for dev environments. I just want to go through like a couple quick examples of some stuff that Dusty does. We're not going to do like a terminal demo or anything, but here's some of the neat stuff that we've done. So in Dusty, we have this concept of bundles. This is what we're going to do to let us mix and match our different applications. So in this example, I have 4 different sets of containers defined, but I only actually want to run my web app. So I can define all of these, which is just like some YAML specs floating around. And at runtime, I can choose what I want to work on, and I can only spin up containers for that. This is a really big deal because it lets Dusty scale out to basically as many services as you can possibly define. Again, it's just like text in a YAML file. And you only have to allocate resources to what you're running at one specific time, which, again, compared to like a VM setting where you have to install everything or layer something like Chef on top of it, is going to be a lot better for you. So when you run Dusty, Dusty doesn't just spin up containers. It goes a lot further than that. So if I start my web app container here, yes, I'm going to start up my web app container, but Dusty's going to take care of the plumbing to get the code on my Mac into that container at the location where this Flask app is going to be expecting its source files to live. So by doing this, I don't have to write code inside a container. I don't have to SCP stuff around on my own machine. I work on my Mac where I expect to be able to work. Dusty takes care of this stuff for me. Dusty also takes care of plumbing around port access and host forwarding. So I can say this container is going to run a service on port 80. Please make that available at localflask1.com on my Mac. Dusty's going to take care of all of that. So that's going from my Mac into the VM, into the container, and I don't have to worry about it. It works basically the same way I'd expect it to work if I were operating on my local system. As I mentioned, Dusty also knows about our code. So I can ask Dusty, if I made a change to my web app repo, I can say, hey, Dusty, please restart all of the containers that use this. And it will take any container that's relying on this code, and it will restart a new version of it with the updated code. And this allows us to not have to constantly manage that map in our mind, like, oh, these 6 containers use this one repo, so I should restart these 6. You should let your tools do that kind of work for you. The last thing I'm going to talk about here is Dusty has first-class support for the test flow we talked about. So if you've ever used like Drone.io or any Docker-based CI, it's like very similar to what they do. You basically say, take a container with, in this example, my Python stuff in it, and rig it up to a temporary container running this database. So in my example, we're going to start up a Mongo container and a Python web app container. It's going to run the test. It's going to tell me whether or not they worked. And then it's going to tear everything down again. And it's like nothing ever happened. We are still making huge improvements on speed. But this takes about 4 seconds right now. So it's not like super slow. And it's definitely better than doing something awful like testing against a database that you're not actually running in production. And these tests are all shared through the same YAML files that Dusty uses for everything. So one person in my organization can write the test, send it out in YAML, and then everyone can just say Dusty test my web app with the Mongo test, and all of this stuff is going to happen for them with a totally fresh database. So that's just like a quick preview of some of the stuff Dusty can do. The Docker ecosystem has come a long way towards making it actually achievable to run your dev environments in a containerized workflow. And there's still a lot of work to do, but it's, if you looked at it 6 months ago or a year ago and decided it was way too hard, you were right. But take another look at it. There's been a lot of work done, and the official Docker tools are coming a long way as well. Sorry. So what have we talked about? A lot, like a lot of stuff. Containers, it's possible that containers are going to give us a way out of the development environment problems that we've been having. And as the Hacker News commenter showed, like, we do have serious problems. Like, I personally had serious problems until very recently. And I think a lot of you probably have serious problems with your dev environments. The containers might give us a unit of scalable isolation that lets us make our development environments more reproducible, much easier to reason about, and solve a lot of the problems we saw from having a big complected ball of crap in the sort of pre-container like VM world. But it's definitely not a solved problem. There is definitely still a lot of work to do. And everyone in this room and everyone in this community can help with that. If you are having, if you or someone you know has had problems with their dev environments, please help them. So there is basically a gold rush right now to solve this problem. Not like literal gold, but probably like internet and open source gold. If you have an idea for how to fix this, if you want to help us or other people fix it, there is so much work to be done, but I think it's very exciting what we could actually achieve. We've been using Dusty internally. All of our engineers have been using it for about a month now. And it's very early, obviously. We're still making like huge improvements to how it's working. But already, I got one of those fancy tiny MacBooks like a couple weeks ago. And I had my dev environment up and running in about 10 minutes. And I think the dream is within reach. And we just need to try to get there. So if you want to help, if you want to look into using Dusty, if you just want to tell us it's terrible or tell us it's awesome. Let us know what bugs you run into. Help us fix bugs. Help us write features. There's so much work to do in an early open source project. And it's all written in Python. And it's well tested. And if you would like to help out, I would love to talk to you about it. So that's all I have today. If you want to learn more about Dusty, you can go to dusty.gc.com. It's free, MIT licensed, all that fun stuff. You can download it. You can run it. We have a Slack organization, which is public, if you'd like to come talk to us and other Dusty users. We are looking into doing a more detailed talk on Dusty specifically at a Docker New York City meetup coming to you hopefully shortly. And I am available on the GitHubs and the Twitters at Thieman. And that is all I have. Thank you. And so somehow we actually have a lot of time if anyone has some questions. We also have stickers with this awesome tornado guy on them, whose name is Dusty, if you'd like stickers. Question back.
Are you concerned with the development environments? Are you concerned with having enough parity to the production environments? Are you running your production environments on Docker as well with identical containers, or I don't know, how do you address that? Or are you concerned with that?
Okay, great question. So the question was, are we concerned about our containers being different in production and in development, and how that affects us? We actually had a really interesting story on how we got to Docker. We started with Docker in production first, which when I tell people that, they look at me like I'm crazy. So we actually had a production first rollout of Docker. All of our containers are designed to run in production. The way we're using them locally is we use the production containers as basically a shortcut to get to something that we know basically works. We throw our development and our like local code into the container. We make sure we've updated our requirements if we need to, and we run that. So we have a policy now. I told someone to do this once, where if the images need to diverge, then you need to make a separate image for development. So the way we're not doing it like totally, these must be the same, but in practice, the amount of divergence between those two images, so which an image is like a saved version of a container, tend to be very minimal. It's like, oh, I really want this. I need build essential in my dev image, and I don't need it in production. So it's not a pain point that we've had. We personally haven't had. Did that answer your question at all?
Yeah.
And feel free to talk to me after. Question?
What about, how does this relate to like Ansible and stuff like that?
Great question. So the question is, how does this relate to Ansible and other configuration management solutions like Chef, Puppet? The answer is there is a place for both solutions. So as I mentioned, we're running Docker in production. We're also running Chef in production. We use Chef to basically get a box to the point where it can run our Docker stuff. And that's obviously a very necessary thing to do. I do not believe, I don't really see a reason you would continue to need configuration management in the development environment space with Dusty. We're not using it. Basically, the way Dusty works is it spins up a tiny Linux VM for you using boot to Docker, which is the predecessor to Docker machine. And the amount of config management we do in there is we install rsync and we like set up one symbolic link somewhere. It's like very, very, very minimal. So I don't think in the containerized dev environment flow, you're necessarily going to need configuration management. If you don't have containers, you probably do need configuration management because you need something to help you manage that big ball. And in production, I think for sure, you definitely need config management in production today. Good? Question?
Tell me more. So I thought you could put everything into your Docker file, everything that you would have in Chef, right?
So the question was, could you put everything into your Docker file? The answer is yes. You can do basically anything you want to. As with many things in life, the question isn't whether you could. The question is whether you should. So one of the paradigms that's sort of contentious in the Docker community is whether each container should be limited to running one process. I think a lot of the isolation benefits I talked about sort of depend on that paradigm. You can put anything in a Docker container that to your heart's desire, really. So you could take a VM with 18 things running in it and change it to a Docker container with 18 things running in it. I don't know why you would do that, but you certainly can. And there are some more complex services on the public Docker registry that use this model. So like we run a Sensu server that runs like 6 processes in a single container. And that's actually really hard because if one of those dies, but it's not the one that Docker is looking at, then the container just sort of happily keeps going about its business even though your server is down. So a lot of the tooling, and I think they're even moving more towards this, is built under the assumption that you're running one process, one container. And if you don't do that, the onus is sort of on you to have some sort of process management inside there. Question?
What's your method of debugging code when it's running?
So the question is, what is my method of debugging code? So usually what happens right now with Dusty is I go to like local.website.com, I get a 503, and I'm like, well, that's weird. I asked Dusty what happened. Dusty says the container died. And then you run, we have a logs command. So the way Docker does it is your standard out and standard error from, this is a good example of the one process that Docker is monitoring, gets exposed via a logs command that you can run. So in my example there, I could have run Dusty logs, my web app, and it would say like, here's standard error. And at the bottom, there'd be a stack trace, generally. Okay, great question. So if I want to add like a breakpoint, or let's say like PDB, right? So if I want to add an interactive debugger, Docker gives you a mechanism to attach straight into the running process, including attaching your standard in. So I could say, okay, container, run this Python app. The Python app has a PDB breakpoint in it. And then when I hit that, I could say, okay, Docker, I need to attach to this container, and that's going to drop me straight in there. We do not have built-in support for that in Dusty, so you do have to learn a Docker command to do that, which is potentially something we should fix. But Docker does give you that capability. Questions? Concerns? Comments?
So do you still see, or do you still use virtual environments in Docker containers with your Python apps, or the fact that you can have separate Docker containers sort of mitigates the need to use virtual environments?
So the question is, do we still use virtual environments for our Python apps in Docker containers? The answer is no. The container provides a level of isolation deeper than what we would get with virtual environments anyway. And as long as you're running one process or one Python app, there's no need for further isolation within that container. So that's just one example of something that has been simplified. In this example, you're sort of trading one for the other. But if you're running multiple languages, or you're running, like us, we run multiple different databases, different services, different worker processes. The advantage of Docker is it's the same framework for every problem, really. So it may have a higher startup cost than just learning virtual env, but it scales, it's just sort of a constant cost. Whereas otherwise, as you're adding more tools with more virtual environment-like stuff, you have to learn more and more and more, and that's going to be more of a linear cost. But with Docker, you can throw basically anything at it that's not like a kernel, and it's going to isolate it, and it's going to work the way you think. Question?
So Game Changers, amateur team management, Dusty doesn't seem to be in the charter or something like that. How did you convince your management to invest in it, and is there any concern that they may get tired of it?
That's a great question. So the question is, this doesn't seem like it's in our wheelhouse, basically, to use a sports metaphor immediately as a sports company. So how did we get to build this tool? I have so many answers floating in my brain. So first of all, when I pitched it, I said, look, we can write, we're going to take our designer, Ryan, who's really awesome, and he's going to make a logo that looks like it could be for a minor league baseball team. And you're going to love this. Our CEO, Ted, who is amazing, basically gave me an order. He said, I need a hat with this logo on it, and the man sitting in front of you has that hat on right now. So that worked. So to get to your actual question, we had a serious problem. We had a serious problem with our developers fighting against their dev environments all the Like I said, we used to be on a Vagrant-based VM system. We had no way to really manage changes to that system. It was very ad hoc. We certainly weren't doing it as well as we could have been, but it was just really a nightmare. We were facing the prospect of, we have 4 people joining in 2 months. Getting them on our dev environment system is going to be a nightmare. Every time someone adds a new service, so we had our principal engineer added a routing layer between our stuff, between like our incoming traffic and our services. And so he had to get that change out to everyone running these VMs, and there was just like no way to do it, and it was chaos, and everyone's dev environments were broken for like a week. So repeated pain. We had been using Docker for about a year in production. As you can tell, I'm sort of chief evangelist / Kool-Aid drinker on the Docker team. We knew that we could solve our development environment problems this way, so we wanted to take a stab at it. And from the business perspective of like writing Dusty, it was not a hard sell because we were having such a hard time, and we really needed something that was going to let us scale out and onboard people faster, manage our stuff faster. Also, I guess I should have mentioned this explicitly. Since we moved to Docker in production, we found ourselves adding more and more like microservices because it became easier and easier. But it would be really easy to spin up XYZ in prod, and then you say, how do I roll this out locally? Oh, you don't. You just break everyone's stuff for 3 days, and they come to you and it breaks. So in terms of ongoing support, that's a very interesting question that we've been wrangling with. Right now, we're actually still working on Dusty like pretty seriously. Jordan, who is sitting in front of you, is working on Dusty full-time right now and gearing up for a totally awesome release in a couple days. But in terms of ongoing support, in terms of promises I can make, we're all using it. So our company is dependent upon it. Our developers are dependent upon it. If we find something better, we will, it's probably, if we find something better enough that we love it enough to move to it, it's probably like actually like legit better. And I hope Dusty can be part of the path to get to something better, but the actual path for us going forward isn't like codified. Other than right now, we are for sure supporting it. We are all using it. I love the project personally, and I think it's great. I think the problem with any open source project you start at a commercial company is how do we align this? But for us, it was really just a no-brainer because of how much pain we had. I rambled for 3 minutes just on that question. Are there any clarifying questions you would like to ask? Because you're looking at me like I've totally failed you. I'm so sorry. Oh.
No, I think it's courageous. I wish you well, but I don't know the whole environment, the containers and Docker's moving so fast. This could be something that dies out. It could be something that really takes off. You don't know. Right?
You're totally right, it's an awesome sort of, the way we went about building this product, it was very similar to how our feature teams build products for our users. It was really cool for us because our users sat like a couple feet away. And so we would ask them, we're thinking about making this thing happen. How do you feel about that? Well, how fast is it? Well, it's this fast. No, it's not good enough. And then we go back to the drawing board. So we've been iterating on it pretty well. We're cutting releases about once a week now because it's still a very early stage. We're still adding like big features, big improvements. And so far, the feedback we've been getting internally has been pretty good. And again, we have a public Slack org if you want to chat with us, or there are actually like real people on it using it who don't work at my company. And you should totally get their opinion on it as well. Okay, last question. Yeah. Yeah. So the question is, how do I get code from my laptop into like 6 different containers that are all relying on that code? And the answer is when Jordan Singleton over here, who is on the Dusty team, releases his new major release, that's going to happen for you very seamlessly using NFS. So basically what we do is we rig up network shares and Docker volume mounts that, again, Dusty's doing all this for you. It's going to get your code into a place where the container can see it. And the container is transparently going to say, like, read this file. And it's going to go through into the container's file system, into the VM's like kernel space, through NFS on your Mac in our example. And that is all going to happen completely transparently to everything. Important detail, yeah, Dusty only works for Mac right now. The reason for that being, if you're using Linux on your desktop, two things. One, you don't have the pain of using a virtual machine. And two, statistically, you're probably more likely to be comfortable with all the crazy terminal stuff. So we're hoping to do Linux pretty soon, but right now it's Mac only. I'm getting the red stop. You guys are awesome. Thank you.